The things that you will have to know this week is how to find the domain of a rational function, how to find the vertical and horizontal asymptotes of a rational function, and how to find the x and y intercepts of a rational function. So the first thing we're going to talk about is the domain, or what is a rational function, first of all. A rational function is a quotient of a polynomial functions. It can be written in the form f of x equals nx over dx. So if I gave you something like, let me turn my marker on here, it works a little bit better. If I gave you something like f of x is equal to, let's say, 3 over 2x plus 4. This is a rational function, and the graph of it would be a rational function also, because it's numerator over denominator, polynomial function on top, polynomial function on bottom. Where polynomials, in general, the domain of a rational function of x includes all real numbers except x values that make the denominator equal to 0. Much of the discussion of rational functions will focus on the graphical behavior near the x values excluded from the domain. Now, I will tell you that that is not a real good definition, because if you take a look at this problem right here, it says determine the domain of the function. Okay, so the first place I would start is all real numbers except, right? Because remember, it's all real numbers except what makes a denominator equal to 0. Okay, so most kids, what they would do is they'd go along and they'd say, okay, I'm going to factor the denominator, and the denominator factors very easily down to x plus 5, x minus 1. And most kids would say, oh, my domain is all real numbers except -5 and 1, because it's whatever makes the denominator equal to 0. That is not correct, okay? Because if I factor the top, I get x plus 5, x minus 5. So realistically, this x plus 5 crosses off. That means that -5 does not make the denominator equal to 0 because it crossed off. What happens on the graph? Well, in the graph of this function, you would end up at -5. There would be a hole in the graph. And we don't discuss that a lot in this course, but in calculus, or if you go into higher math classes, that's what happens. If ever you get a function that has a 0, or if the function, a factor crosses out on top and bottom, you'll have a hole in the graph, okay? So in this problem, the only place that the denominator is equal to 0 is x equals 1. So my answer is all real numbers except x equals 1. So I'm going to give you an example of another function. I'm just trying to get one that would work. Okay, so if I had, let's say I had x squared minus 4 over x plus 2. Okay, so I'm looking at this, and I would ask a student to graph this out. Most students would not know how to graph. But remember, if you factor this, you get x plus 2, x minus 2. And some kids would say that the function is not defined at x equals 2 or x equals -2, but that's not true. Because look what happens here. This crosses out. So this function is defined everywhere. The only problem is at x equals -2, I know there's going to be a hole. So this graph right here is exactly the same thing as this graph right here. So x minus 2, well, that's pretty easy to graph. Go down to -2, my slope is 1. So my graph would look something like this. The only difference with this graph and this graph is at x equals -2, which probably is right here, there's a hole in the graph. There would be a hole here. So this graph is right here. It's this graph with a hole in it. So it is defined at -2 because it crossed off there. It just happens that there's a hole in it. So it's kind of an interesting concept with graphing. You know, this looks like something really tough to graph, but in reality, it's not. Okay. Now, also look at this function. Is there any horizontal asymptote here? Oh, this function continues in both directions. There's no horizontal asymptote. And remember this function. I'm going to write it down so I can come back to it, because there's no horizontal asymptote there. And we're going to talk about vertical and horizontal asymptotes in just 1 second. And if we know what the graph looks like, we'll be able to tell what the horizontal and vertical asymptotes are. All right, so let's take a look here. This is a function, a rational function. It says find the domain. Well, in this problem, it's pretty easy. It's all real numbers except 0, because 0 makes the denominator equal to 0. So it's undefined. Now, if I was going to graph this thing out, I know that there's a vertical asymptote. Any place that makes the denominator equal to 0, there's a vertical asymptote. And I usually draw vertical asymptotes as a dotted line. So my graph is going to look something like this. And you can see, as my graph gets closer to that asymptote, it just shoots straight up. It never crosses it. Now, is there a horizontal asymptote in this problem? There sure is. A horizontal asymptote would be right here. So I have a vertical and a horizontal asymptote in this problem. The vertical asymptotes are always x equals, so the vertical asymptote is x equals 0, and the horizontal asymptote always is y is equal to, because it's a horizontal line, and this one happens to be y is equal to 0. Now, am I going to be able to find the horizontal asymptotes? Yes. You're going to be able to find them very easily, but this is what this function would look like. What is the domain? All real numbers except x cannot equal 0, because it makes the function undefined there. All right. So how do we find vertical and horizontal asymptotes? Vertical asymptotes, super easy. Whatever makes the denominator equal to 0, that is a vertical asymptote. Okay, so let's go back to this problem. 1 over x. The vertical asymptote is right here, x equals 0. There's also a horizontal asymptote at y is equal to 0. Now, how do we find horizontal asymptotes? Whew. Vertical asymptotes, super simple. You just make whatever makes the denominator equal to 0. But remember, factor it first. Factor the top and bottom, because if it crosses out on top and bottom, that is not a vertical asymptote. Be very careful on that one, because a lot of students, they just factor the bottom. Oh, I got it, and they'll cross out they'll say all the vertical asymptotes. No. So here's a couple graphs, like this one here. The vertical asymptote is x equals -1, and this is the function. Okay, I have the function 2x plus 1 over x plus 1. And we can find the vertical asymptote easily. We just find out whatever makes the denominator equal to 0. X equals -1, vertical asymptote. How do you tell what the horizontal asymptote is? Super simple. If the highest power is the same on top and bottom, okay, so the highest power is the same on top and bottom, then you just take the numbers in front of the top and bottom, so 2 over 1. So my horizontal asymptote should be 2 in this problem. Oh, look at that. Horizontal asymptote equals 2. Awesome. Okay, in the next problem, I've got 4 over x squared plus 1. No vertical asymptote. You don't see any place that there's a vertical asymptote. Why not? The denominator, x squared plus 1, it never equals 0. It would be an imaginary number if we wanted to find that, but not. Now, let's see how we find the horizontal asymptote. Well, the highest power on top and the highest power on the bottom are not the same. So if the highest power on the bottom is bigger than the one on top, okay? So I always call this a big over small, because a small over big, because I have a small exponent on top. I really have none, to tell you the truth, and a big one on the bottom. If you have small over big, then the horizontal asymptote is always going to be 0. Because a small number, let's say small number is 1, big number is like this, it's very close to 0. So that horizontal asymptote is 0. So if the variables on top and bottom are the same, we just take the coefficients out in front. If I have a small exponent on top, big exponent on the bottom, horizontal asymptote will always be 0. And then the opposite, remember that problem that I had before? I had x squared minus 4 over x plus 2, and we graphed that out, and we came up with that line like this. There's no horizontal asymptote here. Why? Because I have a big exponent on top, and I have a small exponent on bottom. So the top is bigger than the bottom, so I say that's a big over small. No horizontal asymptote. That is how you find horizontal asymptotes. If they're the same, if the exponents are the same on top and bottom, you just take the coefficients in front of the power or the variables. If the top is smaller than the bottom on the exponents, then 0 is the horizontal asymptote. And if the top is bigger than the bottom, there will be no horizontal asymptote. Okay? And the next slide will give that to you algebraically or mathematically wise. I look at that and it's like, but it really is, it just basically tells us how to find horizontal asymptotes. It says when n is less than m, the graph of the line has y. Okay, so n is less than m, so I have a small over a big. Y is equal to 0. If n equals m, then it's the two numbers in front of the variables. And if n is greater than m, it has no horizontal asymptote. So these are the mathematical ways of saying how to find a horizontal asymptote. Okay, not exactly the way I do it. I just look at the highest power and top and bottom. But that's basically saying the same thing. All right, so here it says find all vertical and horizontal asymptotes of the graph of each rational function. Okay, awesome. So here I have a small over big. So my horizontal asymptote, okay, small over big, what is that? That's going to give us a y is equal to 0 for horizontal asymptote. And then my vertical asymptote, I don't think I'm going to have one, right? Because I set my denominator equal to 0, and I solve, so I put -1 over here, so I have 3x squared equals -1. I divide through by 3, x squared equals -1/3. There's no way x squared equals, so there is no vertical asymptote. Now you can check yourself by graphing it out. Go to decimals, graph it out. You'll see that there will be a horizontal asymptote at y is equal to 0, and there will be no vertical asymptote. In this problem, horizontal asymptote, oh, the powers are the same. So I just take the numbers in front. So that's 2 over 1. So that's my horizontal asymptote. Y is equal to 2. Horizontal vertical asymptote, well, if I factor the bottom, I got x plus 1, x minus 1. So I have 2 vertical asymptotes. X equals 1, x equals -1. So pretty easy to find horizontal and vertical asymptotes. So let's do some practice problems from this week's assessment. Here it says, find the vertical asymptote. No, only asks for the vertical. Okay, so the bottom, the top does not factor, so no, it doesn't factor. So the bottom is x equals 8. That is going to be my vertical asymptote. That's it. Whatever makes the denominator equal to 0. How about this one? It says determine the horizontal asymptote of the function. So now I have a big over a small. Remember what we said, big over small? No horizontal asymptote. Okay, so there should be no horizontal asymptote there. Boom, letter D. No horizontal asymptote. Now, how do I find where a rational function crosses the x and y axis? Super simple. If I want to find where it crosses the x-axis, I put 0 in for, because remember, if something crosses the x-axis, the y value has to be 0. If it crosses the y-axis, the x value has to be 0. So if I want to find the x-intercepts, all I do is put 0 in for y. If I want to find the y-intercepts, I put x in for, I put 0 in for x. So really easy to find x and y intercepts. So here it says, find the x and y intercepts of the rational function. Okay, I always think that finding the y-intercepts are easiest because I put 0 in for x. All right, so I put 0 in here. So that gives me -6. If I put 0 in there, I get -6 over 3, which is -2. So my y-intercept, so I know my function is going to cross at 0, -2. Where does it cross? The x-intercept. Now, and why do we do this? It helps us graph this out. I know that at x equals -3, there's a vertical asymptote. I'll do this in blue. Because if I was going to graph this, this is what I would do. I'd say, okay, there's a vertical asymptote at x equals -3. I know there's a horizontal asymptote at 1 because of so I know there's a, so these are my horizontal and vertical asymptotes. I know it crosses at 0, -2, and where does it cross the x-axis? Well, then I set it equal to 0. X minus 6 over x plus 3 is equal to 0. I would cross multiply. So anytime you have a 0 here, it makes it nice. So you end up with x minus 6 equals 0. bring over the 6, x equals 6. So I know that at 6, 0, this function is going to cross the x-axis. So 1, 2, 3, 4, 5, 6, so someplace up there. All right. So I'm thinking my graph is going to look something like this in there. And there's probably, because usually rational functions are like this. So without even knowing how to graph this thing, that's kind of, those are the things that go through my head. It's like, where's my vertical asymptote? What's my horizontal asymptote? Where does it cross the x-axis? Where does it cross the y-axis? And then I can kind of plot the graph. In this problem here, it says find the x and y intercepts of the rational function. Well, again, I like putting 0 in for x. It makes it easy. So I get 64 over 6. 64 over 6 means 4. And then if I want to find the y-intercept, that is the y-intercept, the x-intercept, I have to set it equal to 0. I would just cross multiply, and I end up with x to the third plus 64 is equal to 0. Bring the 64 over, x to the third is equal to negative 64. So x equals negative 4, because negative 4 times negative 4 times negative 4 is negative 64. So I'd end up with negative 4, 0. So it looks like letter B. So finding the x and y intercepts are pretty easy. So